We'll have time for questions following the presentation, and we should be dismissing right around 10 o'clock for those who need to get back home as early as possible. The Grand Canyon is the world's most amazing natural wonder. Next to the Grand Canyon, everything that man has done fades into insignificance. There at the Grand Canyon, something amazing that God has done. We all realize that. What about the Grand Canyon catches our attention? You know, it's been called the one of the 7 greatest natural wonders of the world. And people who rate the natural wonders, I believe they rate the Grand Canyon #1. That's been by general consensus, the #1 natural wonder of the world. There's something about the Grand Canyon that fascinates us and catches our attention because we look there and we see something awesome sitting before us. The world's most amazing display of strata in the Grand Canyon. Look how wide the canyon is. 4 to 18 miles wide. It's an incredible feature. I'd like to talk about my trek through the Grand Canyon over a period of 25 years, from evolution to creation, thinking about the Grand Canyon. When I first saw the Grand Canyon 25 years ago, I was thinking like an evolutionist. I had been trained as an evolutionist, and I was reading about evolution of the canyon in the books. And over a period of years, I've gone, you might say, through a tortuous evolutionary process to becoming a creationist and looking at the canyon. An immense canyon, 4 to 18 miles wide. Notice how deep the canyon is. In places over 5,000 feet deep. Notice the inner gorge of the canyon, how narrow and V-shaped. Everywhere you look in the Grand Canyon, you see the depth, immense depth. It's hard to visualize the depth till you see and look down in the canyon and see something that man is, man's effects in the canyon. Everything that man has made fades into insignificance. You can take all the trash that man has made and accumulated and put it in one of the side canyons with plenty of room to spare. That shows you how big the canyon is. Take a look at the evidence about how long the canyon is. From the satellite photograph, the false color Landsat photograph, you can see pretty much the whole length of the Grand Canyon through the northern Arizona-Colorado plateau. It's an amazing feature, over 217 miles long, not counting 60 miles or so of Marble Gorge upstream. It's an immense feature. It's incredible in its size. You stand on the rim of the Grand Canyon, like right here, you can only see part of the just part of the Grand Canyon, but it's 217 miles long. I did a calculation to estimate how much material has been eroded away just to form the erosional form of the Grand Canyon. 4 to 18 miles wide, 3,000 to 5,000 feet deep, 217 miles long. You come up with a rough number, almost 1,000 cubic miles of material has been eroded away to make the Grand Canyon. That gives you an idea. 1,000 cubic miles, that's an incredible amount of material removed to just form the erosional profile of the present Grand Canyon. That is incredible. I've been leading trips through the Grand Canyon. Trips through the Grand Canyon now for 8 years. This will be the 9th year that I'm leading trips. And on the book table, you'll see information, this Grand Canyon brochure, about our next trip to the Grand Canyon, April 8 through 16, 1989, the ICR's 9th annual Grand Canyon Creation Venture. We've had immense popularity to our Grand Canyon trips, and we've opened it to the general public. And we lead raft trips, bus tour, and hiking groups into the canyon every year now. And it's a yearly event. And a spectacular way to observe God's handiwork in the creation there in the Grand Canyon. Here we are with some of the rafts. We go with these enormous rafts called J-rigs. They're 38 feet long, 17 feet wide. They hold about 20 people each. And here are some of our rafts pulling in some of the deep gorges of the canyon. It's a very beautiful way to see the canyon. See a bunch of the canyon. 89 miles of the most scenic up with most of the strata. That's the part we float in our raft trips. floating on the Colorado River on the raft is like the life of a soldier. Long periods of boredom, short periods of terror. Okay, you're running 30 rapids in the 89 miles, 30 major rapids, and they are some big ones. Okay, and most of the time it's calm water, and with the motors we make pretty good time through the canyon, observe the rock strata, and then we come to the rapids and short periods of terror as we go through those rapids. But the boats are able to negotiate the rapids with a measure of passenger safety. We also do a bus tour. We've gone bus tours all around the canyon. Here on the south rim, we're having worship on Sunday morning. What better way to worship the Lord than on the rim of the south rim of the canyon? This was on Easter one time. We had Easter worship on the rim. We observe Grand Canyon, also Bryce Canyon, Zion National Park. We go to Wapatki Indian Ruins, to Sunset Crater, an old volcano, to Walnut Canyon, cliff dwelling, to Meteor Crater, out to Petrified Forest, the logs, petrified wood area, out to a Painted Desert. We're going to do a float trip this year on Lake Powell, over to Rainbow Bridge, the world's longest natural arch. Just some amazing things that we can do on an 8-day trip in northern Arizona, bus tour by Luxury Bus. It's one of the most enjoyable ways to see a tremendous area of northern Arizona and southern Utah. Here's our bus tour. Then we have hiking groups. Perhaps the most direct way to see and physically most strenuous is by hiking. But it's probably the most rewarding because you get the direct contact with the rocks and with the plants and animals of the canyon. And they are laborious hikes, steep trails, but we have water on the creeks and everything, and it's a very beautiful time of year. April is the best time of year to be there in the canyon to enjoy it. And look at the scenery, incredible. Every time you see the canyon, you get a different view of it. It's amazing. Take a look at the strata in the canyon. The origin of the Grand Canyon. What do the rocks say? As we look at the Grand Canyon, we immediately are called back to our origins. We know that there's something there very powerful that's commanding our attention, but what is it? What do the rocks say? Origin of the Grand Canyon, what do the rocks say? Unfortunately, the rocks don't say anything. They just lay there. That's rather distressing to a geologist. You wish they could talk and tell you the real story, or wish you could get an instant replay or something like that. But what do you see? Just a bunch of flat rocks laying there. Spectacular exposures, though, and really the rocks don't say anything, and the origin of the Grand Canyon has to be interpreted. This next diagram shows the interpretation of data. Okay, the fossils and the strata of the Grand Canyon are interpreted. How is it that we can come to different interpretations? Interpretation A, the evolutionist interpretation I once held for the Grand Canyon, or interpretation B, the creationist interpretation of the Grand Canyon? How is it that one person, myself for example, can have two quite different views of the Grand Canyons almost simultaneously? What going on there? Can you tell me why that occurs? Here it is. Notice the top of that diagram I shared last night. Presupposition set A, or bias A, leads through the data to the interpretation A. If you begin with evolutionary presuppositions and biases, you'll determine your interpretation of the data to come up with an evolutionary interpretation. If you begin with creationist assumptions, or bias if you will, you'll lead you through the data to a creationist interpretation. The question is, which is more satisfactory and which explains the greatest number of facts with the fewest assumptions? In our educational system, we do not use this two-model approach and analyze the presuppositions to our understanding of data. We are force-fed evolution dogmatically, exclusively, and protectively. And it leads us only to evolutionary interpretations. But we need a creationist interpretation to balance the evolutionary dogmatism that we see in our culture today. Here's some important issues about the Grand Canyon. This will form the outline of my lecture this hour. The important issues about the Grand Canyon, I've listed 8 issues. And your answer to these issues will determine how you interpret the Grand Canyon, the origin of the rock layers and the fossils and what they mean. First, the first issue is the erosion and the character of the landscape. What is the landscape around the Grand Canyon? What does it represent? We want to consider that. And probably the most interesting first question that people ask when they see the immense amount of erosion at the Grand Canyon. Then we want to talk about the extent of strata. What does that suggest about the origin of Grand Canyon? Then we want to talk about the distance of sediment transport. We realize that these are particles of chemicals and class of material that have been moved. Well, what do they suggest about the distance of sediment transport? Number 4, the rate of sedimentation. How fast did the strata accumulate? We want to look at that issue. And another one is erosion surfaces between strata. What do the boundaries between these formations and these layers represent? Long periods of time or short periods of time? And we want to look at the deformation styles in thick sedimentary strata. How the strata have been bent as the Grand Canyon area has been uplifted. And what kind of deformation has occurred there. And then number 7 and 8, I'm not going to deal with very completely tonight. Number 7, the interpretation of the fossils, has been dealt with by Dr. Gish in his fossil record lecture on Tuesday night. He talked about the interpretation of fossils. Let me just say briefly, if you wanted to go to the Grand Canyon and find a finely graded progression of fossils from simple to complex demonstrating the amoeba to man evolutionary story, you would be severely dismayed at the Grand Canyon because you find marine fossils at the bottom and the top and about the same level of complexity from bottom to top. Interpretation of fossils leads better to a creationist interpretation, many have said. And then the radioactive isotope abundances, that 8th issue, I dealt with yesterday. I gave you some evidences for why the radioactive dating techniques do not give accurate ages for those strata. So I will deal with the first 6 here in some detail and just go through and lead you through my way of thinking about the Grand Canyon. And as we have enjoyed the Grand Canyon, seen many things. First of all, let's talk about the strata and the strata nomenclature of the canyon before we get to those issues. Geologists draw strata column diagrams like this, showing the sequence of strata, and then they like to put names on them. They give the strata layers names, and so we can begin at the bottom of the canyon in the most deeply buried rocks. They're not stratified at all. The Vishnu schist and the Zoroastrian basement rock complex. Creationists have suggested this represents the first 3 days of creation week, maybe the initial creation on day 1, and modifications day 2 and day 3. Evolutionists say that this might be the original crust of the earth billions of years ago. Then up here we see some diagonally tilted strata, the Bass limestone or dolomite, the Hakatai shale, the Shinemu quartzite, the Dock sandstone. Diagonally tilted, a sequence of strata, some places over 8,000 feet thick. And evolutionists have thought about that being the Precambrian strata, the Proterozoic strata. They're supposed to have been deposited a billion years ago or so. And creationists have been thinking this might be the late stages of creation week. You know, day 3 of creation week, the Bible says, God said, let the waters be gathered together into one place and let the dry land appear. Evidently, the continents were thrust up out of the universal ocean. And we could have had an immense amount of sedimentation beginning on day 3 of creation week. So some of this could be related to day 3, perhaps. Then you notice this unconformity or surface of erosion. The diagonally tilted strata are overlain by flat-lying strata. And that surface might represent the onset of the flood, right there, the onset of the flood waters, and the scouring of the pre-flood surface, and the upheaval of the pre-flood crust of the earth, and the diagonal tilting of those layers, and then the beginning of the flood. And so we could have flood deposits up above it. The Tapete sandstone being the lowest flat-lying layer, the Bright Angel shale, the Muav limestone, Temple Butte, Redwall limestone about halfway up, a very important cliff-forming limey layer. Supai Formation about 900 feet thick, a very heterogeneous association of sand, shale, and limestone. Then we have the shale layer, the Hermit Shale, and the Coconino Sandstone, a prominent white cliff former, this one right here. And then we have the limestones forming the rim, the Toroweep and the Kaibab limestones. Looking at it here, you can see the crystalline rock, the Vishnu schist and the Zoroaster granite down in the inner gorge. The Colorado River is down in there somewhere. Then we have the flat-lying sequence here, the Tapete sandstone, the Bright Angel shale, the Muav limestone. Then we have the red wall forming that cliff. You can see that everywhere, that red wall cliff. Overlying it, 900 feet of supai, sands, silt, and limestone formation. Then the Hermit shale, and then the Coconino sandstone, that cliff former, the white cliff cream-colored layer, and then the Toroweep formation or limestone and the Kaibab limestone on top. That forms the Grand Canyon sequence that we see. Anyway, that's the strata that we have to deal with. Let's go and talk about this first issue, which is the erosion and the character of the landscape. As an evolutionist, I once held the evolution uniformity model for the Grand Canyon, and I proposed that the whole drainage basin of the Colorado River was an evolving landscape. Here you see it, an immense drainage basin, Arizona, Utah, part of Nevada, Wyoming, Colorado, New Mexico, even down into Mexico it goes. It's an immense drainage basin, the drainage basin of the Colorado River. I suppose that was an evolving landscape, evolved over tens of millions of years. I suppose that was uplifted, that whole Colorado Plateau area was uplifted 70 million years ago and began to erode. And the immense drainage basin was the result of tens of millions of years of erosion. A creation flood model, however, might propose that this drainage basin is a relic landscape, a leftover feature from more potent agents of erosion that operated in the past. And now we have minor, small acting agents at the present time that are just slightly modifying the landscape. In other words, the landscape is not evolving continuously over millions of years. It's more of a static or dead landform that's being altered, a relic landscape, in other words. Well, those are the two models that we might consider for the landscape. Let me call your attention to the fact that the Colorado River and the whole drainage basin of the Colorado River and the Colorado Plateau is very unusual because most rivers, 2/3 of the way down from the headwaters to the ocean, have broad, low-lying plains, like the Mississippi River. Take a look at the Colorado River here in the Grand Canyon. 1/3 of its way up from the Gulf of California, it has very high plateau, 8,000 feet above sea level on both sides of the river. That is something very unusual about the Colorado Plateau. In other words, the river is positioned through the plateau, not around the plateau, but through it. And that's a mind-boggler. First mind-boggler is the incredible amount of erosion. The second mind-boggler is that the river is positioned through the plateau, not around it. Rivers, I thought, like to take the easiest way and divert around a large uplifted area. Well, let's look at some of my ideas about the landscape. Here you see the Landsat photograph showing the plateau in northern Arizona, and the false color Landsat photograph shows green as red, so there's forest on top of this plateau. It's 9,000 feet above sea level here, sloping off to 7,000 feet and lower, the southern part of this. It's called the Kaibab upwarp in northern Arizona. And the river doesn't go around the upwarp. The canyon is positioned through it. And that's a major mind-boggler. Not only just 1,000 cubic miles of erosion, but the river cuts through the plateau. In a way, you might say the Colorado River is the river that flows uphill. Okay? It goes over the top of that hill. How could it do that? Okay, and I thought to myself, that's amazing, isn't it? Here's what I thought. I thought of the ancestral Colorado River. I proposed, and I was thinking in my mind that 70 million years ago, Arizona and Utah were a low, flat plain near sea level. And we had the ancestral Colorado River flowing down from Colorado into Utah, through northern Arizona, off toward Nevada and California, and then down into the Gulf of California. This broad, low-lying plain was near sea level. We had this meandering river on it, say. Then what happened? Over a period of millions of years, the plateau slowly uplifted. The Kaibab upwarped even more. And what happened? As the Kaibab upwarp flexed, the Colorado River entrenched its way into the upwarp. As fast as the upwarp occurred, the Colorado River cut down into the Kaibab upwarp and as the plateau uplifted. That's called the ancestral river theory. It proposes that the Grand Canyon was cut by the Colorado River over an immense period of time, 50 to 70 million years. It's an immensely elegant theory, isn't it? It's simple, it's rational, it explains everything in terms of processes and configurations that I can see going on today. And it commanded my attention. Geologists had thought about it, 120 years ago when John Wesley Powell first floated down through Grand Canyon. He thought in terms of the uplifted ancestral Colorado River cutting down through this plateau. It's an immensely popular theory. We see it on signs in the Grand Canyon. We hear about it in our textbooks. On television, the idea of the Colorado River evolved the Grand Canyon over an immense period of time. 20 years ago, as I was thinking about this theory, I became distressed by some facts. You know that the present Colorado River through northern Arizona is moving roughly 1/2 million tons of sediment a day down the channel of the river. 1/2 million tons of sediment a day over 70 million years would amount to a mass of sediment roughly 1 million cubic miles. Okay, so off to the west of the Grand Canyon, what should you find? An immense delta deposit from the ancestral Colorado River, deeply buried with a volume of 1 million cubic miles. What do we find directly west of the Grand Canyon? Do we find sand, silt, and gravel layers deeply buried? We find a limestone layer, the Muddy Creek Formation, the Halapai limestone, several hundred feet thick. And limestone is formed by calcium carbonate from an ocean, showing that no major river was there for any great period of time. And there is no delta deposit of sand, silt, and gravel measuring millions of cubic miles, 1 million cubic miles, anywhere near that. We do have a delta for the Colorado River, but it's a surficial deposit, and we can find roughly 1,000 cubic miles of material from the erosion of the Grand Canyon, but no mass of sediment approaching the colossal quantity that would be needed by the ancestral Colorado River as it eroded over tens of millions of years. Most geologists these days have junked the idea that the Grand Canyon was cut by the Colorado River. Sounds like heresy, but it's right. Most geologists who know about the delta deposits and the limestone on the west have dismissed the idea that the Colorado River evolved as the plateau land was uplifted. There is no ancestral river. Geologists, by and large, who know about the area have dismissed the idea the Colorado River cut the Grand Canyon. It is a heresy, isn't it? Because that's what seems to be the normal idea about rivers, is they cut their own canyons. Yet here we've got this impossible situation. We can't imagine millions of years of erosion. I was thinking further about the Grand Canyon, and I came up with another theory. It's called the gully theory, the precocious gully theory. That's what I call it. The Kaibab upwarp occurred in northern Arizona. Notice here's north, there's east and west. And what happened was it occurred, and the ancestral upper Colorado River did not flow westward through northern Arizona. It flowed off to the south and maybe around, joined up the Gila River and flowed through southern Arizona. The ancestral river did not flow across northern Arizona. The Kaibab upwarp occurred without the river crossing it. And I thought to myself, the upwarp would have occurred rapidly, and it could have been breached recently by a drainage that came in. Notice this drainage, this gully came in from the west, eroding material out from the east to the west, and we have the gully developed, what I call the Grand Canyon Gully. And I thought about this theory. Here it is. The gully got so deep that it captured the whole headwaters of the ancestral upper Colorado River, diverted it through northern Arizona, creating the Grand Canyon. In other words, the Grand Canyon was not cut by the Colorado River, but by gully drainage. And then the final effect in the diagram would be the complete diversion of the Colorado River through the canyon, and some final sculpturing to form the Grand Canyon as the Colorado River had arrived in that canyon. That's been called the stream capture theory, or the precocious gully theory, even by the advocates. They use that. As I was thinking about the gully theory, it became difficult for me to reason that way. I had no reason to suppose that the gully would be directed from west to east across northern Arizona. There was no downsunk trough that would direct the gully. In fact, the slope was from north to south, and the gully should be diverted to the north, not through to the east. As I think about the gully, there's no fault or structural reason that would direct the gully through northern Arizona. And there is no other Grand Canyon gullies on Earth. I was attributing the Grand Canyon to the world's most amazing natural accident. A gully, runaway gully erosion that captured the whole drainage basin of the upper Colorado River, diverting it through, and I was making the Grand Canyon by a gully. A friend of mine and I were talking about this problem of the gully forming the Grand Canyon, and I was telling him about some of the difficulty I was having, and he said, you know, I've got a theory. Have you ever thought about the Grand Canyon being a collapsed cave? You know, we could have had an underground drainage of the Colorado River through northern Arizona and some caves, and then the cave collapsed. As my friend and I were talking, we smiled at each other, realizing the ridiculous extremes that our logic had led us in order to explain the Grand Canyon and the erosion of the Grand Canyon. You know, at Mount St. Helens, we had a very powerful display of erosion of Grand Canyon. What happened was we blocked the drainage of the North Fork of the Toutle River with landslide debris and volcanic ash material. At the top of that cliff, right there is a man standing for scale. 140-foot cliff. We see a little drainage running down through there. Do you think that that gully or river formed that drainage? No, it was formed by catastrophic drainage. Mud flows and other processes formed that drainage. And it brings to mind a third theory for the canyon, a catastrophic drainage theory or flood theory. And of course, the North Fork of the Toutle River is unblocked by the mud flow on March 19, 1982. For 2 years, the drainage was blocked, and there was a natural dam there. The dam was breached by mud in basically a day, and it formed that miniature Grand Canyon of the Toutle River. Let's look at that, see if we can see it. Here we go. Take a look at the miniature Grand Canyon of the Toutle River. There's the main drainage going down through there. Here's the right drainage. There's two other drainages come in there. A whole pattern of drainages, assuming something like the Grand Canyon. Notice this. We have the flat surfaces north and south of the little Grand Canyon and the Toutle River. We have the flat uplifted areas north and south rims of the Grand Canyon. Notice that the breach did not occur straight through. It kind of meanders. Notice the breach kind of goes back and forth there. It's not straight breach. This dam failed, and as it failed, a collapse occurred in the side canyons. And look at, we have these cup-shaped side canyons that have many of the same features around Grand Canyon. And then notice we have these gully erosion coming in, intersecting. We do see gully kind of features around Grand Canyon. So many of the same features are produced there at the little Grand Canyon. 1/40th scale model there at the Grand Canyon. As we're sitting there thinking about the erosion of Grand Canyon, some type of catastrophic drainage theory occurs and comes to mind. Do you know that the Havasupai Indians, who today live in the Grand Canyon, tell perhaps the oldest theory for the origin of the Grand Canyon? One of their ancestors survived a great flood in a hollowed out log, and the drainage of the waters off the earth from the flood carved the Grand Canyon. And all the peoples of the earth are descendants of this ancestor who survived the flood. And all the peoples, including the Havasupai Indians, are to live in peace, and they're supposed to live in peace in the canyon. It's interesting that many of the aspects of what the Indians say about their legend goes back to the true biblical account, I believe. Can you imagine a sheet-like flow of water as the floodwaters were draining off, beveling off the top of this plateau? There's severe erosion on top of the plateau, beveled it off pretty much flat as the arching was occurring. And then can you imagine channelized flow perhaps cutting the canyon, channelized drainage or perhaps better, this uplift occurring here, the upwarp, blocking the drainage and forming a lake that was behind the Grand Canyon. And you know, off to the east of the Grand Canyon, there are lake deposits showing impoundment of water behind the plateau, the uplifted Kaibab upwarp, direct physical evidence of some of the activity. Here you see the cup-shaped side canyons. You're looking up, they are not pointy and V-shaped like normal erosionally formed gullies. They're very cup-shaped. See the amphitheater-headed side canyons? That could form by collapse. As the catastrophic drainage occurred, the canyon would be cut down and the sides would fall in. Oops, let's keep on going here. I'll give you some more thoughts here. Here's some more of those cup-shaped side canyons. Notice that many of the rocks of the Grand Canyon have this black to brown stain. They're getting stained. That's an accretionary coating that's covering the rocks. Those slopes are not now retreating or evolving. And creationists look at that and say, hey, there's stagnant and stationary landscape. Actually, the canyon is filling in. It's getting that stain and coating. It's like a varnish that's covering everything. Here you see the Vishnu schist. It's green, but it's got a black coating on it. The Zoroaster granite's normally pink to white, and it's got a pink to brown color to it there. It's all getting coated, and that's a stagnant or stationary or relic landscape. And many of the cliffs in the Grand Canyon have a red stain from some of the red sandstones above. They come down, and so it gets a decidedly red or brown or even black nature to it. And that suggests that large parts of the canyon are stagnant, not evolving at the present time. Well, that leads to the whole idea of catastrophic drainage and the Grand Canyon being a breached dam. A new theory for the origin of the Grand Canyon, a catastrophic theory that avoids the obvious fallacy of a gully cutting the canyon and goes to a more realistic model. We have an actual canyon at Mount St. Helens to show us. Now, how about another issue, the extent of strata? What do evolutionists and creationists suggest about this extent of strata? Evolutionary uniformity model would suggest that strata are deposited by local to regional sedimentary agents. For example, sand would be deposited along the floodplain of a river, or where a river goes into an ocean, a delta, or along a beach. And so those are very local to regional in extent, and so that's the type of strata that we should see in the Grand Canyon if you reason from the slow and gradual uniformity model. Creation flood model would suggest, however, that the flood is of regional and continental scale, even intercontinental scale. So we see regional to continental distribution or extent of strata. Allow your eyes to feast upon the continuity of strata in the Grand Canyon. Very continuous, extensive strata in the canyon. Call us to thinking about the canyon. Take a look at the Supai Formation. We have sandstones and limestones that are extremely extensive. Here we are in one of our hiking groups going down looking at the sandstone layers in the canyon. Sandstone layers are continuous throughout the 217 miles long canyon and very little change in thickness. There's no wedge or delta-like deposits in the sand bodies there. They're very flat and blanket-like. Brings to mind some type of shallow water sheet flooding or something like that, quite different than modern ocean. And that immediately brings to mind the flood, something like the flood. Here you see some of the Supai sandstones that are very extensive over enormous areas. No channel development or levees or deltas and those kind of things. Nothing, it looks like shallow water material. The lowest flat-lying layer in the Grand Canyon is the Tepete sandstone, and there it is. It's very extensive throughout the Grand Canyon. Go from California through the Grand Canyon up into Colorado and to Utah. It's found in Missouri and Illinois and Wisconsin, eastern United States even. It's a very extensive pan-continental blanket sand body that sits above that surface of erosion underneath it. Here we have the crystalline rock, the metamorphic and igneous rock of the inner gorge, the Vishnu schist and Zoroaster granite underneath the Tepete sandstone. That erosion surface is certainly significant, but how about that blanket-like sand body? Isn't it significant? Well, extent of strata, and now an allied subject, the distance of sediment transport. Where did all this material come from that was accumulated here at the Grand Canyon? Take a look at individual strata layers. For example, the Coconino sandstone, some of the Supai formations there, or even the tapetes down at the bottom there. Many of those formations look like they've come from great distances. Evolution uniformity model would propose local to regional sedimentary distribution patterns along rivers or creeks or something. And the creation flood model would propose regional to continental extent of strata. What do we see in the Grand Canyon? Take a look at the Coconino Sandstone. It's over 350 feet thick in the Grand Canyon area. It thickens up to over 2,000 feet thick southward underneath Flagstaff, Arizona. It covers 32,000 square miles in northern Arizona, and it's continuous elsewhere. It's an incredible sand layer. It has been estimated there's 2,000 to 3,000 cubic miles, 3,000 cubic miles, 2,000 to 3,000 cubic miles of sandstone in this one formation. And where did that come from? It could not have come from the underlying Hermit Shale because it contains no sand grains. It's mud. It's clay. It doesn't contain large amounts of sand, so it can't be the source. So the sand must have come from somewhere very distant. Some people have suggested from Wyoming or someplace way up north. But it brings to mind regional and continental distances of sediment transport. The Supai sands and silts lay directly on the red wall limestone underneath it. Here you see the red wall limestone forming this massive cliff over 500 feet thick, and there's 900 feet of the Supai above it. The Supai sands could not be derived from the limestone below because very pure limestone. 98% pure calcium carbonate cannot be the source of the silicon dioxide or quartz sand grains that form the sandstone layers in the Supai. Therefore, the Supai must be from some distant area. Everywhere we find the Supai, we find the red wall below. So it can't be the source. So the source must be somewhere else, great distance away. Flood model suggested. Now, how about the rate of sedimentation? As an evolutionist, I once believed that sedimentary strata were formed slowly over millions of years, perhaps 1,000 years for every inch to foot of sedimentation. And creation flood model would suggest fast, several feet per hour to hundreds of feet per day, something like that. And it could be rapid rates of sediment accumulation. Here we see the lowest flat-lying layer in the Grand Canyon. What do we see? Sandstone layers, the Tapete Sandstone. And at the base of the Tapete Sandstone, we have giant boulders, big boulder deposits. And those boulder deposits have fascinated us on many of our trips through the Grand Canyon. Here is that erosion surface underneath the boulders, and there's the boulders, the lowest flat-lying layer in the Grand Canyon. Shinumu quartzite boulders 4 feet across here. We did some more study, and as I mentioned last night, we have some very big boulder layers. Here's 4-foot diameter boulders. In one area, we have a giant boulder deposit. There's my field assistant for scale. There's a 15-foot diameter boulder. In the base of the boulder deposit, in the bottom of the Tapete Sandstone, the bland and sluggard boulder doesn't move, and you must give it a big kick to move it. And there is evidence of catastrophic boulder movement. Can you imagine 200-ton boulder? How do you move that? It takes a tremendous amount of power. Can we imagine this being a gigantic mud flow deposit or something? That's a possibility. So catastrophic agents forming strata. At Mount St. Helens, we had very rapidly accumulated strata. For example, here's the June 12, 1980 pumice flow deposit, the hurricane velocity surging flows. Deposit this layer deposit. Take a look at the Tapete Sandstone. Notice its layering. I had thought that those layers form very slowly. Now that I've taken a look at these, I have my doubts about it. Take a look at the very layered appearance of the June 12, 1980 pumice flow deposits. Extremely well layered. And maybe that can explain rapid deposition of those layers over there. Take a look. Even the finest lamination can be seen in the June 12th deposits at Mount St. Helens. Look at the micro-thin lamination formed by a hurricane, something moving at 100 miles an hour, challenging our way of thinking about that stratification over there in the bottom of the Grand Canyon. Now we have diagonally tilted layers in the Grand Canyon. The Coconino Sandstone is flat-lying layers, and the diagonal layers. I remember talking about that last night, that cross-bedding occurs in sandstone. Here's the Coconino Sandstone, 350 feet thick. Here's my field assistant for scale, Notice the diagonal layering in the horizontal layering generally formed by enormous water currents, we believe. Currents must have been moving at 2 or 3 feet per second. An immense ocean covering Arizona, 32,000 square miles in area, moving 3 feet per second, something like that. That's a massive flood. That's something that's unlike any ocean we see today. That could be building these up, underwater dunes that have been beveled off, rapid sedimentation again. And then we have unconformities, these erosion surfaces in the canyon. What about those erosion surfaces? Evolution uniformity model would propose that long time breaks occur between the strata. The creation flood model would say short time breaks on erosion surfaces between strata. Evolutionists now are starting to admit that individual strata layers can form rapidly. Okay, like at Mount St. Helens. They're starting to realize that, but they're putting the great time breaks for their evolution of life on the breaks or gaps between strata. That's not the highest form of logic, I think you'll appreciate. To put the lack of evidence for your theory in missing strata levels between bedding planes of strata. Nevertheless, they do now, and more want to put the missing time in between the strata, not within the strata, but between the strata. And the great unconformity right here, that's that erosion surface between the flat-lying Tapete sandstone and the underlying Precambrian diagonally tilted strata. That great unconformity has been suggested to be 500 million years or half a billion years to maybe even 1 billion years in duration. An incredible amount of time would be involved in the evolutionary way of thinking about that. A creation flood model, we could have rapid flood scouring of these surfaces and not long periods of time. Take a look at the base of the Tapete sandstone. Could this be the onset of the flood as it came upon the earth? That's about as close as we could get to where Noah or Adam walked. And I don't know if we could find any evidence of the pre-flood civilization down there, but anyway, this is the beginning of the flood deposit, best as I can ascertain. And can you imagine the scour of the pre-flood surface that occurred right along that surface, and all the flood strata deposited on top of there. Here you can go right to the contact between the flat-lying Tapete sandstone and the underlying sandstone strata here tilted at an angle. And right there, is that half a billion years missing there? You might expect to see a soil profile and deep weathering and channeling and all kinds of things. It's a very flat surface. And I'd challenge you, if you want to go see it someday, take a raft trip through the canyon. We always stop there and look at the great unconformity. Whatever your theory about the Grand Canyon, that must be something major. Is that the beginning of the flood and the scour of the pre-flood surface of the earth? Or is that a time break of immense duration, half a billion years? The physical evidence doesn't appear to be there for long periods of time. There's another unconformity up beneath the red wall limestone, separating the Cambrian Muav from the Mississippian red wall limestone. Right in there, it's supposed to be 150 million year missing, a gap. All of the Ordovician, the Silurian, and most of the Devonian strata are gone, and several hundred feet, maybe even 1,000 feet of strata might have been deposited, but it's gone. Evolutionists suppose that it's right in there. We both know it's right in there, but what does it represent? Long period of time, or slow and gradual process, or rapid erosion? The contact is right here. We have limestone overlaying limestone, Muav limestone over Temple Butte limestone. A closer look at that shows the remarkable nature of the contact. Somewhere in here, we don't know exactly where, I think it might be right along in there somewhere, the limestone, the red wall limestone sits on top of the Muav limestone. And what is amazing is the lack of evidence of weathering, of pitting, of cave development, of solution channels, of boulders and karst terrain, everything there. It's perfectly parallel above and below, and you ask yourself, is that evidence of 150 million years missing? You could erode the continent down to sea level in just 14 million years. So in 150 million years, you could erode the continent down to sea level 10 times. And immense duration like that, maybe you'd expect to see some very significant features. We don't see them there. Well, anyway, in the Coconino sandstone sits on the Hermit Shale. And what do we see right there? A knife edge contact. But elsewhere in Arizona, there's 600 feet of strata between those two zones, or those two formations. Thereby, the evolutionists have suggested tens of millions of years of missing time right along that contact or boundary there. But you don't see much any discoloration or soil development or lag boulders or channel development or anything there that would be proof of a great age. And so where is the missing time? Doesn't appear to be there. So as we look at the unconformities and the erosion breaks between strata, we put a big question mark. Is there great periods of time between strata? And as an evolutionist, I once suggested long time breaks between strata. Now I'm doubting whether the long time breaks exist. How about the deformation styles in thick sedimentary strata in the Grand Canyon? We see two different styles of the way the strata would be bent. The evolutionary uniformitarian model would propose that the strata were accumulated in the Grand Canyon over an immense period of time. They were deeply buried, perhaps 10,000 feet deep under other strata. Over hundreds of millions of years, pressure and temperature and time would have solidly cemented the rocks. Then they were uplifted to form the plateau over 8,000 feet above sea level there. What style of deformation would you predict? Brittle deformation, faulting of the strata as the plateau is uplifted. You'd expect the strata to break and be broken along a fault line. A creation flood model would say, no, the strata did not accumulate over long ages. These strata might have accumulated rapidly during the flood year, and the uplift of the plateau would be shortly after that, maybe just years, months or something. And so these strata would not be solidly cemented. Therefore, they did not have to fail in a brittle fashion by faulting. They could have deformed in a plastic fashion. They could be deformed as a fold structure, folding rather than faulting. Here's the East Kaibab monocline, and you can see where the strata have been warped up. By the way, let me go back and just show you that. Here's where the strata come in from the east, and they buckled up 3,000 feet to form the uplifted plateau. There's the Kaibab limestone at 5,000 feet elevation. It's warped up right in here, 3,000 feet, and it's 8,000 feet above sea level in the North Rim. In the cross-sectional diagram, you can see at 5,000 feet above sea level here, we have the Kaibab limestone. It's warped up, and it forms the Grand Canyon on the east side. This fold structure is called the East Kaibab monocline. We believe that there's buried faults in the Precambrian crystalline basement rock that allow the strata above to be deformed in a plastic fashion, forming this draped mashed potatoes kind of appearance, or the fold structure called the East Kaibab monocline. And we can go right to it and study it. It's one of the amazing features. Look at how the limestone was bent. It did not crack and form a fault, a shifting in the earth. It was buckled up and bent. So that's evidence of plastic deformation, we would suppose. Right there is a man for scale. Okay, here's the Tapete sandstone, the lowest flat-lying layer comes in, and for hundreds of miles it's level. All of a sudden it goes into vertical orientation. See this? It goes straight up into the air, 3,000 feet, and then it connects with the strata on the other side of the form of the plateau. Could that be formed by brittle deformation? Take a closer look at the way the strata were bent. There are two people there for scale. Here you see the flat strata coming in, and they're warped up in vertical position. It's almost as if it was twisted like taffy, leftover mashed potatoes, kind of folded like that. Not that it was brittle rock. I think the average person on the street recognizes that you cannot bend rock like that. It must be plastic. Rocks don't bend to that extent. They break. And so twisted like taffy, very severe deformation along the monocline, suggesting that there was no long period of time. Now the evolutionists propose that these strata, the Cambrian Tapete sandstone, were accumulated 500 million years ago. They lay buried under 10,000 feet of strata, perhaps for 430 million years, till the uplift of the plateau occurred 70 million years ago during the time of the Laramide orogeny. And so what do we have? We should have solidly cemented, deeply buried strata over that immense period of time, I would think, and yet they behave in a plastic fashion. That's better evidence, I think, for rapid sedimentation and rapid upheaval. Well, we've been thinking about the strata of the canyon. Here are some of the important issues that we've talked about. Erosion and the character of the landscape. We've gone over the basic theories for the erosion of the Grand Canyon. The ancestral river theory, the Grand Canyon was formed slowly over an immense period of time, perhaps 70 million years. I once held that theory. That's the idea the Grand Canyon was cut by the Colorado River. Most geologists have junked that idea. They've gone on to the gully or something else, precocious gully theory, making the Grand Canyon by the world's most amazing natural accident, a gully. And then third theory is the breached terrain by catastrophic drainage, a breached dam idea, and that could form the Grand Canyon. Drainage from back here through that area could carve the Grand Canyon. A catastrophic theory in line more with a flood. And then the extent of strata. We see widespread strata, not localized strata, and that suggests widely acting flood agents of deposition. The distance of sediment transport is extreme. We see long distance of sediment transport, not local to regional distances. The evidence in the strata suggests rapid sedimentation. We see erosion surfaces between strata do not require long periods of time. We haven't made a solid case for how much time would be involved between the strata. We don't think it's required we have long periods of time. Those erosion surfaces don't represent missing geologic ages, therefore. And so much of the Grand Canyon strata can be accumulated by the flood. And then the deformation styles in the thick sedimentary strata indicate plastic deformation, no long period of time between sedimentation and deformation, where cementation could occur in between, but a short period of time. And then interpretation of fossils and radioactive isotope abundances. We've dealt with those in other lectures. But as we look at the Grand Canyon, the important issues, we look at all those important issues and weigh them and consider them, it appears that the best theory for the origin of the Grand Canyon is a creationist view. The radioactive isotope abundances, there's that Cardenas lava flow. That gave 1.09 billion years by the rubidium-strontium technique. It gives 795 million years by the potassium-argon technique. Both can't be right. Something's wrong with radiometric dating. Just about every lava flow you can date in the Grand Canyon comes up with divergent ages. In fact, the youngest age for the Grand Canyon strata comes from a lava flow that flowed over the rim and blocked the river. It gave, as I mentioned last night, an age of 1.5 billion years by the rubidium-strontium isochron technique. No evidence, proof positive for great age in the canyon. All of the evolutionary arguments appear to fall in favor of creationist interpretations of the canyon. So a creationist view of the Grand Canyon is in order. And I believe that that's where we're going. We're going to see more and more people realize that a creationist interpretation of the Grand Canyon is in order. What do you see in the Grand Canyon? Really, come now, it's just a bunch of dead organisms buried in rock layers laid down by water all over the earth. Brings to mind a flood almost immediately. And what do we think about? God's holiness and justice. And we think about the sovereignty of God as we look at the strata of the Grand Canyon. A Christian view of the and creationist view of the Grand Canyon. Something to cause us to wonder. An immense memorial to creation and the flood right there. The Creation Week rocks, okay, and the flood rocks. Creation and the flood right there in the Grand Canyon. An amazing story we need to consider, something really relevant for our day. Thank you so much. Okay, we do lead trips through the Grand Canyon. You're welcome to pick up some of the materials in the back of the room, the free material. If you're interested in going with us on the Grand Canyon trip, do pick up this brochure.